The world of automation is undergoing a paradigm shift. This changes everything. Welcome to Universal Automation. The world of plug-and-produce software components, making complex things simple and reliable. Think of it as the dawn of an industrial automation app store. The IEC 61499 standard is the key to portability and interoperability. UniversalAutomation.org is the community managing an industrial-grade reference implementation of 61499. Because no one vendor or company or person can bring about transformation on their own. Universal Automation allows us to use software and hardware in a whole new way to create portable applications and innovative architectures. For the first time, IT and OT engineers can easily work together, combining real-time with right-time to create cost-effective and innovative ways to address complex use cases like predictive maintenance, production optimization, and virtual commissioning. But how does Universal Automation really impact you? Vendors can use the Universal Automation reference implementation to bring IEC 61499 offers to market fast. That means new software revenues, new business models, and new customers. Universal Automation frees industrial enterprises to integrate best-of-breed components and proven in-use software. You can realize step-change advancements in efficiency, flexibility, and modularity with agile operational models. It's time for us to release the full potential of the fourth industrial revolution. Be a part of the community delivering the solution. Join universalautomation.org.
Hi everyone, good morning, good afternoon, good lunch as well, from wherever you are around the earth. And I'm happy to have you and to welcome you to this session of the UAO Goes Live, LinkedIn Live, the first of this year. This session will be a bit special because the topic is about AI services, and we have seen a lot of interest from you when we put on the title AI services and all the content that we will share with you. So we decided to do like this and give you more, meaning that today is the part one of the AI services, and there will be next month the part two. So please enroll yourself as well for the part two. The invitation will come next week. And today, what will be the topic? Today, the topic will be also on the LTU University, so Sweden University, and the Professor Viatkin, the CEO of FlexBridge as well, which is one of the research university research, let's say, company within the university. Hi, Valerie. Come on stage with me. Hi, Valerie. You need to unmute yourself.
I'm sorry. Yes,
so we can hear. Hi, Valerie.
Hello, everybody. Hello, Greg. I'm really happy to be here this afternoon. And yes, thank you for the introduction. I'll talk today about our recent developments in the area of assisting software developers with AI power.
Based on 61499, yes?
Oh, yes, of course. What else?
What else? Let me show your screen and you can go.
Okay, so let me switch to my screen. I'm talking today about a function block assistant. My name is Valery Viatkin. So first of all, a couple of words on who we are. FlexBridge is a startup spin-off research lab at Luleå University of Technology, located in Luleå, northern Sweden. And our expertise is in IEC 61499, decentralized control systems. We also do professional education. And our role, and why I'm speaking today on behalf of FlexBridge, our role is to fill the gap and complement the university with capabilities of companies who can make prototypes of real products and bring it to the market. So that's what we see as our role. And we are very motivated by the challenge of industry flexibility. And we see the solution for industry flexibility in decentralized swarm intelligence. So in the shift of production systems to be automated in a distributed way and controlled with a swarm of interconnected control devices. So from that perspective, IEC 61499 is the only bet these days to have system-level software design for this kind of decentralized automation systems. And that is why we are heavily into IEC 61499. But automation systems, this view on automation systems is impossible to implement if we do not have a corresponding hardware. And FlexBridge, some years back, has developed a totally different kind of automation device that is a very small node, but very powerful node that is directly connected to some set of sensors and actuators, but also on the other end, it's connected to modern communication networks such as Wi-Fi, Wi-Fi 6, but then later also to cellular such as 5G. And this small node we see as a basic block, we call it ICE block, a basic block of future automation systems. So we have prototyped this concept through several research projects and activities. You see several on the screen. For example, at Aalto University, a demonstrator was developed for heterogeneous automation system under the umbrella of universal automation, where ICE block is a part of. We've been into European project with Italian company Repack and automated machines from Repack using ICE blocks. We've been also collaborating with Spanish company HSOL, hovering solutions to automate payload on the drones using ICE blocks, drones flying in the tunnels. So here you see this universal automation heterogeneous demonstrator where ICE blocks is a part of, along with the devices of other universal automation members interoperating and collaborating in a single small example. And we have also used the 5G version of ICE block devices on the same test bed with indoor access point to 5G and proving high throughput and high reliability of communication using this technology. So another ongoing project with ICE block has been and is ongoing yet is a project on using 61499 and 5G in decentralized grid protection. So we have built a test bed where ICE blocks are connected to a powerful simulator of a smart grid system where we reproduce automation of a substation, digital substation, and ICE blocks represent controls of primary equipment within power distribution substation. Okay, so, but today I'm going to talk about totally different thing, not hardware, not ICE block, about software, about a software tool that we are prototyping and developing at FlexBridge. And one motivator for this development has been the recently started European project Medusa, that is manufacturing as a service framework, exploring decentralized secure data exchange and promoting sustainability and circularity. So in this project, where FlexBridge is a partner, we are focusing on a tool that is a function block assistant. And this is what I'm going to talk about in the next part of my talk. So, but I need to start with a little introduction. In IEC 61499, as many of you know, a basic way to represent the control logic, one of the ways, is to program basic function blocks using state machines. So here is an example of from one of our previous projects. One commercial machine was implemented, control of that was implemented as this state machine called in 61499 execution control chart. But basically it is a state machine where in graphical form we represent the sequential logic and behavior of input-output behavior of the controller. So these state machines could be quite complex. And the challenge is how to create this from specifications, from the requirements that automation engineers have. Today, I'm going to walk you through this process. Okay, so let me first explain the workflow of the FB Assistant tool. The basic element of basic technology support that we need for developing IEC 61499 applications is integrated development environment, right? So we know that there are several such environments. For example, Foriak Eclipse IDE or EcoStructure Automation Expert IDE. So this IDE is a basic tool that the developer is using, and developer is creating function blocks, saving function blocks, and building application from function blocks, storing the function blocks in the repository. And then when application is built, it is deployed to a compliant PLC from integrated development environment, and then it starts controlling a real process in the plant. We also often use so-called soft PLCs, where we deploy code on the same machine as we run integrated development environment. And often we use visual simulation to support the commissioning and debugging process of our automation applications. So this is a basic of 61499 development, right? So where is a function block assistant here? So what is the role of function block assistant in this workflow? The developer communicates with the function block assistant using natural language and provides requirements in the natural language. Then function block assistant, from this natural language requirements, creates state machines and lets the developer check those state machines and reply whether these state machines, in the opinion of developer, correctly represent the requirements. So there could be several steps of several iterations upon which the developer comes to a conclusion that now state machine at some stage is good enough and represents the requirements correctly. At that point, function block assistant can connect to the running simulation of process, which is running in the soft PLC of IEC 61499, and do quick simulation of the logic in the direct connection with the model of the process. And after this quick simulation satisfies the developer, the FB Assistant can generate a function block out of state machine and put it into 61499 repository, where it can be immediately taken and used in the classic cycle of 61499 development. So this is a workflow that we envisage for the function block assistant. Now I'm going to walk you through some very small examples of using function block assistant in which you could appreciate better what is going on there. I will use really Mickey Mouse examples, and I have pre-recorded a video to avoid some longer delays with a real live demonstration. So it will be the pre-recorded video, but I will speak over that video. So to illustrate the process, we start with the first example of a pneumatic cylinder, double-acting pneumatic cylinder, which has two actuating signals, move forward, move backward, and two end position sensors indicating the left position and the right position. And also, it would have several buttons, as you can see on the screen, through which operator may interact with the process, with automated process, and the start, stop, and so on. So we start with a testbed, created software testbed, where the controller function block of the cylinder is connected to several function blocks representing model of the cylinder itself and models of the buttons. So this is our virtual commissioning environment where we will want to test automation logic. But this function block itself is empty. You see that inside it's a dummy controller block. It's a basic block in which there is nothing. So we have empty state machine inside. And because of that, if we try to press the buttons in the simulation, nothing will happen because there is no logic inside. It's just an empty block. So as a starting point for development, we open now function block assistant. And we also, in the function block assistant, we start with a dummy empty state machine. So it's in a module that has a couple of inputs and one output, and has an almost empty state machine with just two states, a state for the start, in state initialization, where we set the dummy output to false. So that is where our starting point. Now, the next step will be to add requirements in natural language. So we select some requirement like this. At first, we want to tell the assistant something about our system. So what are inputs and what are outputs, and what is their meaning. And after that, we will give another requirement, which will explain what the system expected behavior is. So let's start with the first one. And we now have this small strip with a text editor where we can select the requirement and insert it to the chat with artificial intelligence. So, and then see how artificial intelligence would modify our state machine. That's our dummy state machine so far. So, selected this text, go insert it to the buffer, and then insert it to the chat. Send it to AI to reason and react on that. So AI have, after some thinking, creates another version of this state machine called dummy A. Now it has, as you can see, populated interface with all this list of inputs and outputs that we described in the natural language. But state machine itself hasn't changed. Only the interface has changed accordingly to the provided requirement number 1. Now we select requirement number 2 that describes what we want the cylinder to be doing. And we say that first it has to retract to the initial position, then it has to go operate in the cycle, and reacting on the start button, it should move to the right, and then wait, and reacting on the next start button, press move to the left. Okay, so we again do the same trick. We insert it to the buffer. We go and give a new name to the expected result, call it cylinder control 1, and then go to send it to AI. Now AI has created the new state machine based on this requirement. And now this state machine already looks interesting. So this state machine describes the behavior of the cylinder according to the requirement. So first retract to the left position, and then engage in the cycle, reacting on the start button. So that looks quite nice reasoning of AI. And we need to analyze whether it is good enough. So here we can see that in the init state, it's still assigning some dummy output variable. So we have not reacted on that in the first instance, when it's created the dummy A version of the state machine here, and it propagated through to the next step. So now we want to correct it, and we type in here in the chat that we want to get rid of these dummy inputs and outputs from the created state machine. So a little editing here in the chat. And after that, we will again pass this recommendation to AI with the hope that it will react on that and correct our model, state machine model. Okay. So selecting, inserting, and finally sending. So here is a result. The assignment of dummy output has been removed from the init state. So now we can see that the state machine becomes quite correct in the eyes of the developer. So it takes first cylinder back to retracting to the initials at left state, at left position, and after that it goes through the cycle reacting on the start button. So the developer should be happy that the requirement has been implemented through this state machine logic. And now what we can do in this function block assistant, we can go and connect to EcoStruxure Automation Expert soft PLC directly from the assistant. So we have here the magic button that we press, and with that we start simulation. So we start the simulation, and you see that in the log window that it goes to state init, then goes to state left, then changes to state at left, and here it's supposed to wait for the button press. That is in our HMI. So we press the button here, and the cylinder starts moving. So we directly, with a state machine created by AI, able now to control the cylinder. And as you remember, the control logic inside Automation Expert is empty. So we are talking from a function block assistant with communicating with the runtime of the soft PLC in the Automation Expert. Now, once we have validated this way, in a quick way from the state machine, we validated the logic is correct. The next step in the use of function block assistant would be to generate the function block based on this logic. So we select this version of the state machine, go to the generate FBT button, and see that the function block file is created. So then we switch to EcoStruxure Automation Expert and see that it's immediately detected the new function block being sent to it, and we need to reload the solution. So we reload the solution, select the function block, and see here is a function block created, auto-generated from the state machine. So you can probably see that they are quite similar in the structure, but the layout is a little bit ugly. We still didn't work on the layouting too much. So now we have this function block within Automation Expert, and we can just go and run the whole system and test and see how it's going to work in EcoStruxure Automation. So we here click and substitute the dummy controller by the newly created auto-generated function block type. And then we need to start and run this function block application deployed to the device. So yes, we save it and then go to deployment, go to device, okay, log in, because device has been unlocked after we re-uploaded the solution. So no syntax errors, so it's everything created correctly. So we start HMI. And then test it by pressing the start button. Again, it works as expected. So second press and it returns to the home position. Okay, so with this, we have demonstrated the first use of function block assistant on the Mickey Mouse example of pneumatic cylinder. Let me now reiterate what we have seen. So we have seen that we started the development with a natural language requirements and with an empty function block with the empty state machine. Then with a couple of iterations, we achieved the working state machine, correct logic. We tested it in a quick simulation, connecting to soft PLC runtime. And after that, we generated the function block, imported it into 61499 IDE, and run it as a part of 61499 application. So that is the first kind of very quick and dirty hello world example of using function block assistant. Now I have another example. I want to walk you through a more complex example of state machine development using function block assistant. That was a series of experiments where we again started with empty dummy state machine. But now for this pick and place manipulator, we have a model of that pick and place manipulator developed long ago, and we used it in our research. So I just implemented connection and implemented development of control for this module. So we start again with requirements written in natural language. And first we give the assistant the list of inputs and outputs. And I intentionally omitted one input just to see how it will, would it be able to create control without that. And then we will give it also description of what we expect this manipulator to be doing. So we will ask it to modify the interface and then add the control logic to that. Okay, so in the first step, the assistant has created, has correctly modified the interface and created this state machine, which has a lot of operations implemented as ST programming language within the state. So then we react on that, saying that we don't like this design and do not use ifs and else statements in the state actions and develop fully state machine-like logic, not combining many assignments in one action. So we give this requirement, and in response, it creates this state machine. So this state machine already looks as a good start. it doesn't have obvious errors, but still some complaints. For example, it returns in the cycle to the init state, which is not a good thing because initialization has to happen once. So we ask to create a separate state for that, and it creates separate state. But some states are not populated with any actions, like this drop-off state that was created doesn't have any actions. And then we again write it a letter asking why is that. So this whole dialogue has taken several steps, and all these steps are recorded in this log. So, and every step, assistant makes some corrections, and we proceed step by step through the process of achieving the desired behavior of our system. So, next requirement, we ask why it would turn the vacuum before reaching the workpiece, which was the case in the step 4 in one state. And the assistant would correct that. Now the vacuum is no longer turned on, it's turned off in all these extension states, peak H1, peak H2, and peak H1, H2. So, and then at the play state, it turns vacuum on. So we go through these requirements and in the dialogue with the assistant, refining the state machine to the liking of the developer. And at some point, we need to remind it that how to reach each tray, because in 2 cases it correctly reaches the tray, but in the last state, in this H1, H2, it wasn't correctly setting output signals. So we corrected that, and we go through the several steps again, and we finally arrive to the step 16. So here in the step 16, we have the resulting state machine that looks like this. And the visual check tells that it seems to be correct. So now maybe it's time to test it. So I will just generate a function block type, go and check whether this logic works correctly in EcoStructure environment. Yeah, so this is a ECC based on the state machine, auto-generated. So we put the name of this newly generated block again here. So we take Control 16, and now we will go and deploy and start. So after we deployed, we press like button, put the workpiece and see the behavior. And oops, that behavior is not 100% correct. On the return, retracting, it's doing some strange thing. You see, it's extending the vertical cylinder while moving to retracting the horizontal ones. So we can complain again in natural language, saying that you shouldn't do that. And let's see how the assistant would react on this complaint. So, yeah. save, as you're already familiar, insert, and send. So what it has created is a version 16a. In this version 16a, if we check the retract state, here in the retract state, it correctly removed, it doesn't turn on the vertical extension. Now it is false. So in the previous version that we tested, it was on. Now we generate another function block type and test it in the EcoStructure environment. So we correct this function block. Select the version 16a and deploy. So let us see if it works correctly. Now we insert workpiece. Yes, the problem has been corrected. Let's see how it reacts on workpieces being in all three trays. Okay. Okay, so that's been a small demonstration of capabilities that our prototype function block assistant tool can do. And now, maybe any questions? I'll be happy to have some discussion with you.
Great, Valerie. Thank you for your time, and thank you for this explanation of how how to write with let's say natural language, how to write function block in 6.14.99. That was very enlightening and interesting. One question. So I don't see any question from the screen, but don't feel shy to ask your question, and Valerie is there, and we'll be happy to answer them. One question which came to my mind is first, we saw that in the way you are doing your prompting for your AI, you'll always start like with input outputs. You gave that to your AI machine, and then you look at the state machine that you successively, let's say, improve. Is that why are you doing this way? Is that like from experience that you should always start with more input output and then from the state machine, or what is the reasoning behind?
Yeah, thank you for the question. I think it meets my kind of common sense expectation. First, when we start from the scratch, we need to tell what the system is, what are automation, and it corresponds to any development of any automation code. So first, you need to know what are your inputs and outputs. What does object have, right? Okay. And this is a basic kind of part of the prompt that we give to the assistant. What are IOs? What do they mean? And what then is a expected behavior description? And after that, the assistant is capable of creating initial version of the automation logic. And then we do in successive steps.
Iteration, yeah.
Iterations to improve it and refine it.
And reach the desired result.
Yeah. And eventually converging to a result that is reasonable.
And can you share with us with which tool behind did you use? Which AI did you use behind?
Currently we are using ChatGPT as a backend engine. Yes, of course, yes. But we are working on different options.
Okay. So you can say that ChatGPT is already a bit trained to to help us draft some function blocks as well with the tool. That's a very good news. And something else is that, and I see the question coming as well in the chat. This function block, this FB assistant. So today it is you use the result to, let's say, copy and paste in the EcoStruxure Automation Expert environment. But is it like an add-in tool of EcoStruxure Automation Expert, or is it like a standalone tool that you could reuse with any 64099 designing engineering?
At the moment, it is standalone tool, but we found ways how to talk to both runtime and the tool itself.
Every time.
So yes, and with the data exchange, we able to do quite seamlessly operation if we run it side by side. The developer could use FB Assistant side by side with EcoStruxure
to test and to simulate and to see what is the behavior which is drawn by the tool.
Yes.
And using some AI, because some of you may have used AI in the past and see as well that the limitation linked with AI, and especially with the prompt engineering, is sometimes the history of the prompting. That, you know, like the AI, when it has too many information, it kind of loses his mind and forgetting what are the first information.
Yes.
And did you test that, and how did you circumvent that behavior from the AI?
I think that's a part of our approach to avoid this. So we are trying to carefully feed AI and feed it with some kind of past knowledge first, and then do it, avoiding two big steps. That's the trick, I think.
That's a very good trick, because it's always, for those using AI, that's always a bit the problem when you want to refine something with many iteration, that at some point the last iteration is like losing the first command that you ask, and you need to re-ask everything from the start. So that's a good way to circumvent that. I'm just reading the chat. I see, very good question. Is the function block assistant capable of creating only one basic function block, or other function block like composite function block? And I think the question behind is, you know, we have a full system, and at the end we have one block. We have all this algorithm, this IEC inside, but is there any subcomponents that we can have to kind of ease the whole development?
Well, I cannot reveal too many details.
Still under development.
But what we have shown today is capable of creating one basic function block, and then we will progress from there.
Yeah, that's very good. And in fact, I very much like your approach, which is very much asset-centric. So you look at the asset, you look at your inputs, outputs. From there, you say, okay, those are my inputs, output. Let's start with that, because I know that my user can touch that. I know which are my action, okay, left, right, vacuum, go up, go down, and so on. And really just from that say, okay, I want to have this behavior, which is in fact, very natural. A very natural way of doing things. And maybe an additional question, I don't know if you have the answer to that, but we saw a lot of what is used, let's say, as a programming language is structured text. We saw mainly. And is there a way to use other like programming language like Python or any other CSS and so on? Or is it like
within function block or within state machine?
Within the function, within the state machine.
Well, of course, it's not a big barrier. I want just to give a small hint. State machines is actually basic design instrument, not only for 61499.
Yeah,
it's a universal design instrument for any digital system, right? So including also 61131. So if you have a state machine, there is a very mechanical approach how to generate 61131.
Yeah.
and I cannot promise anything, but it would be stupid not to implement that. Right.
So the word is out there. The word is out there.
Speaking about like, instead of using within state machine, we do not use any particular syntax of any particular language.
Okay.
So we just have taken ST because of convenience, but it's quite easily to tweak to any other type of internal syntax within state machine. So the state machines we have been playing so far with, they are quite elementary, have quite elementary operations within states. So we were more focusing on ability of AI to build kind of complicated, interconnected logic within state machine, not overcomplicate inside of the states. So that was the focus so far.
Yeah, that's quite interesting.
Because I believe that this is a way how human refines requirements. When we have natural language requirements, they, in most cases, are full of misconceptions and misunderstandings.
Yeah.
So we start with something, and then we visualize it with the state machine. And through that process, we refine the requirements. So what is the end? It's a kind of co-creation process of a human and AI when they go together through this process and arrive to a much better formulated requirements in the form of state machine from what was there in the form of natural language text. And after that, it's quite mechanical implementation process to function block and then uploading and testing it. Yeah.
And another question to you, as you are one of the 64099 fathers, let's say, one of the one implementing the standard, we often have the question, but in fact 64099 is a programming language. So can you maybe help to debunk a bit that? What is 64099?
Well, 64099 is definitely more than programming language. It's an architecture for system level thinking, system description of a system. So it is a way, it's a language, but it's a language to describe a distributed system in its entirety, right? So it includes, on the top level, it includes interconnected functionalities of different nodes and different components talking to each other. And then the next layer as a device is where you deploy this functionality. So this all is a system configuration in 64099. And this is quite unique. No other technology for automation provides these capabilities. So that's why we have to take 64099, because now systems are getting more and more complex, and this need of a kind of system level view is increasing. Also because of AI. Because if we have software-defined description of the entire system, that would pave the way to using tools like our FB assistant.
Yeah.
So we can auto-generate almost everything, reading our minds, right?
Yeah. And iterate and do it.
And iterate. Yeah, I see good question from Zafar Ali in the chat. Yes, that's a good suggestion. It is a kind of so
the question is, will AI assist in debugging the existing state machine designed manually?
Yes, for that we would need to implement some way to import those state machines into our system, not to start from scratch, but start from somewhere. And this is pretty easily. Currently, it's not there, but that would be a nice next feature to implement. And after that, the developer could start continuing improving that state machine.
Yeah. So kind of
natural language dialogue.
Kind of starting with a pretext instead of using the language, saying, okay, I think the system could be like this.
Yes.
I put it in my FB assistant and say, okay, here, this is how I think. Can you make it a bit better?
Yeah.
And then,
actually, in the project that I mentioned, the Medusa project, that is exactly what will be implemented. Because the goal of Medusa project is to develop technologies that help modify existing automation system to implement new requirements. And FB Assistant already can do that. So we just will implement the import, and we probably also could implement import of existing function block into FB Assistant.
Valérie, are you talking about migration?
No. I'm talking, migration is a different thing. I'm talking about system modification.
Good.
So if we have software-defined automation system and need to make production line doing different product or comply with new requirements. So this is like we need to, from current state of automation system, achieve a new state of automation system.
Yes.
And that requires changing some code here and there.
That's quite interesting. I see the next question is, AI helps to identify and generate inputs and output based on required feed from natural languages. And FB Assistant is capable of optimizing existing function block. That's both questions. But I think you answered already.
Well, this, the second one I just tried to speculate about. Yes, so we are not far away from there. I do not fully understand the first part of the question. Generate input and output based on requirement feed from natural language. Yes, the state machine, if I understood the question correctly, the state machine is implementing the function translating inputs to outputs, right? And based on natural language, we create this state machine.
Yeah. And Thomas is saying, please come up with a series of test cases and run them. Let me know the result. That would be a nice feature.
Okay. Yeah. Well, we are looking. That's one reason why I was keen to give this presentation. Is that we are looking to collaborate with industry.
Yes.
To take real industrial cases or cases of industry grade complexity and process them using our FB Assistant. So don't hesitate contacting me, and if you have such cases, and we can demonstrate how they would be processed.
So that's a very call to you, Thomas. You have the email of the Professor Vietkin. You have our contact. We are looking for part 3 of these AI services, which could be directly based on that. So please feel free to give us your use cases so we can run them through the function block assistant and see what are the results. That would be nice. That would be nice. Okay, I think we are good with the questions so far. And I really thank all of the viewers today. We'll have a next session coming up in a few weeks on the part 2 of AI services. So please stay tuned. This will be quite interesting as well.
Yes.
And please come up as well with some of your use cases. Please send them to us so we can even do a part 3 of AI services and just running your own use cases. That would be very nice.
Absolutely.
So
absolutely.
Thank you all. Thank you, Valérie.
Thank you very much.
Thank you, studio. And talk to you soon. Bye-bye.
Yeah. Have a nice weekend. Bye-bye.
Yeah. Thank you. Bye-bye.